some of our logarithmic properties that we learned about on Friday of last week. So I am going to go over just like the top part, just in case maybe you were absent and didn't see it, or if it was kind of a quick lesson, it can't help to have a little bit of a refresher. So there is a Quizlet that is posted that has these log rules. I would recommend maybe going through those flashcards so we can remember them. But I also want to make sure we look at some examples of how we use them. So our product rule for logs is if we have two logs with the same base, they have to have the same base, and we are adding them, we can rewrite it as a single log with the same base that will stay consistent. And then we are multiplying our arguments. So I would multiply x and y. My quotient rule, if I'm subtracting two logs with the same base, I can merge that together and I would divide my arguments. And I want to make sure that the order matters. So the first argument in this was x, so that has to go in my numerator. My second argument was y, so that goes in my denominator. The last rule is our power rule, which is when we have a coefficient, we can actually move that as an exponent onto our argument. So when I rewrite it, we still have the same base, and then I would have x to the power of a, because a was my coefficient. So I'm going to go through 3 examples, and then we'll look at a couple of the practice ones, and then you can practice the remaining. So our first example here, I have log base 4 of 5 minus log base 4 of x. So they do have the same base. Subtraction between two logs means division on the inside. So I'm going to write this as log base 4. And 5 was first, so that has to go in my numerator. And then x was the second argument that goes in my denominator. I am condensing this one into one log, so that would be my final answer. For number 2, I already have one log, so I'm going to expand this one using my log rules. So for my log rules, I can go in either direction. If I have it written like this, I can go this way and condense it. If I'm given one log, I can go the other direction and expand it. So here I notice that 4 and n are being multiplied. So I can rewrite this as log base 2 of 4, because that was the first part of my argument there. And then I add log base 2 of n. This would be my expanded version. If for some reason I wanted to simplify, this log base 2 of 4 does not have any variables. So if I could do that, maybe that would help me figure it out. So log base 2 of 4, well, 2 to the power of what gives me 4? Well, that exponent would be 2. So this whole term here is just 2. And then I still have that plus log base 2 of n. Both of them would be equivalent to our original expression. And then our last example, I have 3 times log base 2 of x. Well, if I have a coefficient, I know I can move that coefficient as an exponent on my argument. So this would turn into log base 2, because I keep the same base, of x to the third. And that exponent is only on the x. It's not on like the whole log together. So if you need to add parentheses like that, that might help you remember what that exponent is having power over. I want to look at a couple examples in the practice part, so you have them in your notes. This one is very similar to this. It's just addition this time. So I have log base 5 of x plus log base 5 of 16. They have the same base. So addition between two logs will turn into multiplication on the inside, so that product rule. So I have log base 5 of x times 16. I'm going to put the 16 first, just because with multiplication, order does not matter, and we typically put the coefficient in front of our variable. If you wrote it as log base 5 of x times 16, that is still mathematically correct. It's just weird to see the variable in front of like a number. So this is how I would write it for number 1. For the second one, I have one log, so I'm going to expand this out. I have log base 6 of 2 times x squared. So something I want to notice is this exponent is only having power over the x, and then the 2 is getting multiplied into that. So since I have multiplication on the inside, that'll turn into addition between my two logs. So I have log base 6 of 2, because that's this first part here. And then I'm going to add log base 6 of x squared, because here the 2 and the x squared is what's being multiplied on the inside. Now I'm not done because I can expand this further. I notice I have an exponent, and so I want to bring that down as a coefficient. So I have log base 6 of 2 plus my coefficient comes down 2 times log base 6 of x. And that would be my final answer. This first part here is similar to this where there's not a variable, but 6 to an exponent of something gives us 2. There's not a nice number for that, so I'm going to leave it exactly like this. So I want you to practice our log rules doing the remaining problems on the front, and then when you flip it over to the back, we have some practice from a little bit ago, so graphing some logs and then some additional questions on the back.